All right, guys, good morning. As Julie said, my name is Dustin Tillery. Have been with Emerson for just about a little over 5 years. Been in the industry all of my life, actively since '96. Started off again running ductwork and progressed from there, from residential ductwork to commercial. From the commercial side, went to the service industry side of the business, and from there to wholesale, and found my way over to Emerson. And it's been a wonderful change, and many opportunities have been presented, and it's been great. So welcome to the class. I'm glad you're here, and I'm glad I have this opportunity to introduce you, if you have not been, to the Emerson E2e building controller, refrigeration controller, and the CX version, or the convenience store side of this controller. All right, so let's get started. All right, so the E2 overview and specifications. What is the controller? What can the controller do? All right, so we have 3 different kinds. 2 of them on your screen that you see now is the BX controller, which is our building side. Does things like controlling air handler units, RTU units, dehumidifications, exhaust fans, lighting controls, interior, exterior lights, power monitoring, indoor air quality, things that you would associate with the HVAC side of the trade. The RX controller is the refrigeration side. The refrigeration controller handles things like our compressor groups, our suction groups, refrigeration circuits, case controllers, anti-sweat heaters on the door cases, food temperature monitoring, refrigerant leak detection, things like that. And the third one is the CX controller, which is an amalgamation of both of those 2 controllers. So we're taking some items from the BX side and the RX side, combining them into one for smaller format stores such as convenience stores, dollar stores, smaller format type of applications. Okay, brief overview of the controller itself. The RX, again, it's primarily used in supermarket and commercial refrigeration applications. The capabilities do vary by series, where the simplest one is the 100 series, which has fewer application instances compared to, let's say, a 300 series or a 400 series. The 400 series, of course, is the top of the line E2, so to speak, where you have other options available, where we can go in and customize the software with licenses, some other description files, and things like that. It also lets us have more capabilities. As you can see here in the charts, we can have up to 72 different analog sensor controls. And what that is basically we're taking an analog sensor, be it a temperature sensor, a pressure transducer, or light level, something like that, and taking that information and then controlling another output with it. You can have up to 64 different case control circuits, 2 different condensers, and up to 4 suction groups. They can be a combination of enhanced suction or standard suction groups. Standard suction being just the compressors and stuff are going to stage numerically, whereas our enhanced suction uses a specialized algorithm to bring on compressors based on the capacity of the compressor and the demand on the load itself. So we can vary the load going down to the cases based on an algorithm in the E2 and just run specific compressors to match that need. All right. The next one here is the building controller. Again, same thing with the capabilities, except that this one there is not a 100 series, just the 300 and 400 series. 400 can handle up to 8 different air handlers or 40 different air handler zones, 48 different lighting control groups, as well as power monitoring, PD control, and pulse accumulators, and up to 64 time schedules. So the BX is very, very capable of handling all of the needs of the HVAC side lighting control of that specific customer's building. And then again, the CX controller is the amalgamation of the 2 controllers put together, whereas you can have up to 8 air handler zones and, where did it go? There it is, 32 different standard circuits. So it does do both capabilities, only in a smaller type of format. All right, so a little bit about the E2 itself, the hardware. It does have a widescreen 800 by 480 resolution. It has a faster processor than our original E2. A little bit faster. It does have more memory and no more battery-backed DRAM. The DRAM is the dynamic random access memory. It's a type of random access memory that stores each bit of data into a separate capacitor within that integrated circuit instead of being backed up by the battery. So no longer do you have to worry about the battery dying and then losing that data. It also has a more persistent storage. And if your customer has an old E2 that had the Echelon board on it, it is now an option that would have to be ordered separately for replacement of the old E2s to the new E2Es. We have a new modem design, a new PIB design, power interface board, where comms 2, 4, and 6 are all now on that board. You do not have to have the expansion cards any longer. Also has a USB port for uploading, downloading files, set points files, or uploading firmware to the controller, as well as a new updated CPU board. Helps to make things faster. The differences between the old E2 and the new E2e, physically the controller is the same size. All right, the keyboard layout is the same size. The main differences that you're going to see just walking up to it is going to be the size of the screen. So first glance, size of the screen is where you're going to notice the biggest difference. On the inside, there have been changes made as well. What you see down here on this side is the old PIB board. This side would be the new PIB board. The easiest way to tell the differences between the two is the battery. The battery is no longer on the new board, as well as the COM ports down here at the bottom. As earlier I alluded that we had expansion boards for COMS 4 and COMS 6, and we took those off and put them all down here on the one board to make it easier for your technician in the field. All right, so the specifications of it. What you need to know here is really the power that it takes. It does run off a 24 volts AC class 2 transformer, but it must be a minimum of 50 VAs. So anytime you guys are selling these out in the field, be sure that your customer does have the proper power going to it in the form of a 50 VA transformer. The dimensions, we're about 11 inches width, 12 inches tall, and about 3 3/4 deep. So it's like this on the E2 and the E2e. They're both the same dimensions. It does take a small platform, so these can pretty much be mounted just about anywhere that's going to be weather tight. All right, the keypad. This is where all of your navigation is going to take place. As you can tell, it is just a standard QWERTY keyboard. Okay, up at the very top are going to be our function buttons, the F1 through F5. Under the F1 is the big red help button. This button is very useful for your technicians out in the field. If they need specific help on a certain subject, let's say they don't understand something that's in the programming of the E2, if they highlight that, press that help button, that will give them topic-specific help on that particular item they have highlighted. The advisories button, the big red bell, is where you're going to go to see any type of alarms that you may have, notices or fails. The home button, if you press that, no matter what screen you're in, will always take you back to the home screen of the E2 controller. Typically, it is the summary screen which shows information like your suction pressures, your rack statuses, circuit temperatures, things like that. Main menu button is used for pretty much all navigation through the E2. That being said, with the E2, there are numerous ways of getting where you want to go via hotkeys. So if I wanted to go see the network summary screen, I could navigate through the main menu, or I could just press Alt, hold Alt and press in, like Nancy, and it would take me to the network summary screen. So we do have a lot of built-in shortcuts in there to make navigating through the E2 faster and easier for the technician. Helps to get them more efficient at their job, which, and then turn saves the customer money, makes them a better operator and technician of the store. Excuse me. And of course, the back button. That takes you back to the previous screen. You'll have the navigation arrow keys at the top, right above the 10-digit keyboard, and then the login, lockout button. The technician can go through the controller all day and look at stuff, But if they want to change something, they will have to log in to the controller with that login to log out button. All right, the E2 hotkeys. Again, guys, these are going to be our shortcut keys, which is going to allow for faster navigation through the E2. You'll probably hear me refer to some of these being like Alt-I for our input screen, or Alt-O for our output screen, or like I said earlier, Alt-N for the network summary. These can also be found on the E2 controller. Through another shortcut key that will show them. All right, so on the inside of the E2, if you were to take this thing and open it up on the back side of the door, is where you're going to find this board right here. This is where you're going to have things like your Cat5 connection up here for communications back to your server, or your Echelon card that is now optional would connect to there as well. Your ribbon cable and your grounding strap are going to be down here, and your USB port down here at the very bottom. Now, please, as it says here, this is the expansion card, if you will. Please do not remove this card. That card holds things like your set points file, your firmware, all the information specific to that E2 is stored on that card. So without that card, the E2 is basically a rock. It's a boat anchor. All right, and again, the compact flash. The use of the compact flash, it has allowed us to increase that system's memory from 8 megabytes to 32. The cards themselves cannot be swapped, so you can't take the card from one controller and go put it into another controller. They are formatted by us in our Kennesaw, Georgia office, and at the boot of the controller, it's where the firmware is stored. So the controller itself is reading the firmware once it's being booted up and loading it into its active memory. All right, the E2 hardware, the Ethernet connection. We do support speeds up to 100 megabytes full duplex. It auto sets itself, defaults to an auto negotiate for the speed. Typically that works out quite well for most customers. All right, the Echelon card. Again, like I said earlier, the old E2, it came standard on there. With the new E2, you have to have a new card, which means a new part number for you guys. All right, it does mount to the back of the CPU board. Network communications for that Echelon network, peer-to-peer communications from E2 to E2, or the old style of air handling and RTU communication was done through Echelon as well. All right, so let's talk about peer networks. The peer-to-peer network is used to allow multiple E2s to communicate with each other. So if you have a store that has 4 E2 controllers on there, and they're all tied into the same server, with a couple of changes in the peer network settings, we can have all of those controllers talking to each other on that same network. Useful for things of sharing data or sharing the alarms. If we have an alarm from the rack, it gets sent down to our building controller, which then allows it to call out to the server to alert the manager or somebody up at the store that they have a problem. It's also used, like I said, for sharing data, things like our global data, where if you just have one outdoor air temperature sensor, we'll say, you can program that into one controller, and then you can share that data to all of the E2s on that same network and use that data for multiple applications. The important thing to note here on this peer network is your firmware. The firmware of the controllers must match. So if you have an old E2 that has the 308F01 firmware, it will communicate to the new E2s on the peer network, provided that the firmware numbers are the same. As you can see in this example, the 3.08F01 would be the same equivalent firmware for the E2e as the 4.08F01. So the PIB board, this is our power interface board. This is where the E2 gets its power to power up. This is also where your COM ports plug into for your communications throughout the devices in the store. The door swaps, before you could just take the door off of an E2, put it onto another E2. Since we've made that change, the boards are no longer compatible, so that door swaps will not work. The backside, the enclosure is the same, but you would wind up having to change the guts from the old E2 to the new E2. And it also has an onboard digital I/O. So part number there, 538-4880, I/O plug can be used on either the E2 standard or the E2 enhanced to give it some onboard input-output capabilities. Okay, E2 hardware and communications. We still have the analog modem capabilities. The PIB does still support the existing analog modem plug-in module. It also still supports the RS-232 plug-in modem module. The RS-485 and modem modules are no longer supported. These were the COM4 and COM6 cards that you may have had previously on the E2s. All right, down at the bottom of the new E2e PIB board is where you're going to find your COM loops, your COM2A, 2B, 4A, 4B, COM6, as well as your termination jumpers. Guys, I cannot express this enough. Please, if your technicians out in the field are having communications issues, the very first thing they should check is termination. Make sure that that COM loop is terminated. Okay, on this screen, we actually showed the layout of our E2e training kits. What you have here on the front is the E2e itself. This being the older style of training unit that we have the multiflex board on it, the XR75s, and the multiflex 168. This is what I would use if I was coming out to your place and doing a trainer-presented training. Your technicians would come in, they would have this unit sitting in front of them, and they would be able to follow along with the presentation, pushing buttons, programming the controller, things like that. I believe we are working on making these available to sell to you guys, the wholesale industry. That way you can have something there to push buttons on as well. Probably not exactly sure on the time frame, but I know we're working on it. All right, so logging into the controller. First thing you got to do, obviously, is have your 24 volts plugged in, right? Then we turn our little chrome toggle switch to the up position or the on position. Green light LED just to the top of the left side should be on. That would be the power button power light right there. You got power, it should be lit up green. All right, so once you got the power on, you're going to see the screen come up and it's going to say user login. Again, guys, you have to log in before you can really do anything besides just look at stuff, okay? Username user, and the password pass is the default for every controller that gets sent out. So if your guy's up there and they don't know what to log in with, username's going to be user, their password's going to be pass, P-A-S-S. That'll get them in there to do what they need to do. Okay, once you're logged in, you're going to see the home screen. In this case, this is the refrigeration controller summary. You'll see things up here at the top. Once you're logged in, that nice little blue head there is just a way to show you that you are currently logged in. If you see two heads there, then somebody else is logged in as well, quite possibly remotely. And if the TM is up there at the top, that means they're looking at everything that you do, which is kind of neat because that's we like to have fun with some technicians out in the field sometimes. We would, just log into a random store and see somebody going through the controller and, maybe hit the backspace on them or something like that just to wake them up to say, hey, somebody is watching and seeing everything that you do. So the E2 navigation side, how do we get to where we want to go and what do we have on the screen in front of us, okay? So at the very top is our screen header. It's going to show you things like today's date. If you're logged in, what type of controller you have, if your caps lock is on, as well as the current time. The helpline down here at the bottom is going to give you information, specific help to the item that you may have on your screen. If it's highlighted like it is there, you can see it says press enter for a list of actions. Pressing enter while that item is highlighted will bring up our actions menu. And then we have the F keys down at the bottom, the function keys, their description. These, again, are kind of like shortcut keys in a way from the summary screen, where if we wanted to go straight to our suction groups, all we would have to do is just press F1. Or if we wanted to go into our circuits, we'd press F3. or if we needed to go into the setup of whatever is highlighted, we would press the F5 button. So the extended information bar, this is going to be on the right side of the E2. This is going to give you information about your alarms. Your advisory summary is what it is. How many fails you have, how many alarms, or how many notices. If they are active, they would be highlighted. Like you can see here on this picture, the notices is highlighted yellow. So we have 2 active notices. Also shows our network overview, which only defined networks are presented. So if we have devices out there that are backnet devices, but we have not yet told the E2 that they are present, it will not show up here. This is good for just quick glances at your communications. If you have a green dot, everything on that communication loop is communicating back to the E2. If that dot is red, there is a device on that loop that is offline. So again, just real quick information there for the technician to see. And then down below that is our controller information, the name of the device, what firmware we have, and then what selected language we have on the screen as well. Now, when pulling graphs or reports, the extended information bar goes away and you have full use of the screen for things like graphs and logs. Okay, so the E2 software, it's highly configurable canned applications, meaning that our enhanced suction group in this controller is going to look the same as the enhanced suction group throughout the rest of the controllers. All of your inputs or outputs are going to have a specific place on where they are programmed in, and that helps keep our programming and stuff consistent throughout all of our customers' chains and uses. Also makes it easier for your technician, because if he's on store A for one call and he goes to store D, he's going to see the exact same setup throughout all of his stores. It also has default point logging, sufficient in most cases, but if you have a customer that wants more data, you have the ability to go in and add those logs or delete those logs as needed. Battery-backed real-time clock and location settings in the E2 itself that allows for things like your sunrise and sunset times, daylight savings times, things like that that are automatically going to be set based upon your location. And then the field-sensitive help. System configuration, of course, it is saved as that compact flash, and the global data application is what allows that sharing of the data between the E2s on the common peer network. Okay, so navigating through the controller, again, menu button is going to get you everywhere you need to go. You press the menu button, you'll have things up there such as suction groups, condenser controls, circuits, sensor controls, your configured applications, which are the applications in the controller itself. You have the ability to add or delete an application, go into the system configuration, or just see the status all from the first button. So the one we're going to look at first is going to be the, system configuration. So if we press menu and then number 7, that takes us to our system configuration page. From here, we can go in and we can define our inputs, the temperature sensors. We can go in and we can name them. We can set them up specifically for what type of sensor we have, be it a temperature thermistor or a 5-volt, 200-pound PSI pressure transducer. We can go in and set that particular input up through the input definitions. And the same with the output definitions, only there you're specifying a relay state. You know, is it open while it's active or closed while it's active, that type of thing. The system information menu gives the access to more E2 setup information. That is going to be stuff like your general controller, your time and date, passwords, user access, service actions, things like that are going to be in the system information menu. And then we have the remote communications, which is where you are going to go in and you're going to set up your modem status, your modem setup, your dial-out setup, or your TCP IP addresses, things like that. Then your alarm setup is where you're going to go in, you're going to set up your alarms. Logging setup, same thing. Network setup is where you're going to go in and you're actually going to set up the network itself. This could be things such as seeing the network summary, connected I/O controllers, or adding new devices you would do from that menu, as well as any router setup or controller associations. The global data is accessed through this page as well, and so is the licensing features. Licensing, you know, if you have a specific controller out there that, let's say, has a device on it that has to have a license. So you would have to know that once you put this new controller on, you would have to wind up getting a new license for that feature to be active. Kind of the same thing there whenever you're getting your Excel or something like that. They give you a license number, you enter, and then it gives you access. Same concept. All right, so the application status screen. This would be the screen that you would see if you were to go into that specific application. The example we're given here is our enhanced suction group. On this screen right here, we see things such as the name of the group or our real-time suction pressure here. What is actually at that transducer? In the parentheses, we would have our set point. What is our suction pressure set point? That would be easily seen by the technician right there. Below that are the stages of compression that we have, what type of compression they are, be it a digital compressor, a regular compressor. If we had an unloader, it would be signified as UNL for unload. We have the capacity of the compressor here as well as the state of the compressor, be it on or off. Now, if we have a point where a compressor has proof failed and it is in alarm, this little square would be highlighted red. Next to that, we have our cycles count, and this is reset over a 24-hour period. So you can just quickly glance at it and say, wow, compressor number 1 has only cycled 9 times and, you know, the past 16 hours since midnight. And again, the status. If there's an oil fail or if the compressor is ready to run, you're going to see it right there. To go into the setup, we push the F5 button. F5 from any status screen is going to take you into the setup of that particular application. On that status screen, you'll see the tabs, or excuse me, the setup screen there, you'll see the tabs C1 through C0. These are the tabs that you're going to use for going in and programming things like your set point or your inputs, your outputs, your stage setup, what type of compressors we have. Things like that are going to be done through the setup editor. To navigate through those tabs, 2 ways you can go about it. You can use the F1, F2 keys, F2 being next, F1 being the previous tab, or you can go straight to the tab that you need by holding Control and pressing the corresponding number. Like in this example, we're holding Control and pressing 7 to go straight to the C7 stage setup tab. A little bit faster than having to tab through every single tab that we need to go through. Now on the screen, you'll notice that the C4 is blank. Good. 1 second, let me get back to it. The C4 tab is blank here. Reason being is because of what they call conditional visibility. So if you don't need that option, or if that option in this case, it's our enable float, if this was changed from no to yes, then we would have another tab come up here for the float tab, which would allow us to go in and set up our float circuit for that particular application. So conditional visibility, if you happen to see a blank tab there, that's the reason why there's an option that is not checked for the need for it. All right, pressing the big red bell button brings up our advisory history. This is where you're going to go in and you're going to see any and all alarms. I say all alarms. It stores up to 200 alarms and prioritizes them from the newest, highest priority you will see at the very front, just like here in this example. If you will notice, let me go back one more screen. Down here on the bottom on our helpline, it tells us what these N's and these R's mean, right here next to our state. So an N means that it's returned to normal. The R means that it has been forced to normal. If you see one here with the asterisk beside it, it means that nobody has acknowledged it yet. That's even though it has returned to normal, nobody has gone up and said, hello, I know you're there, thank you very much, kind of a thing. All right. You have the dash, you know it's been taken care of. Somebody has seen it and acknowledged the alarm. All right, so the actions menu. This kind of goes back in here to our enhanced suction group, where if we have a specific item highlighted, we can press the enter button on it and it will bring up our actions menu. That will vary depending on what type of application you're in. If we're in, say, like we are here, our enhanced suction group, and we want to graph our suction pressure, we simply highlight that value, press enter, brings up our actions menu, then we would choose number 1 for a graph or number 2 for a log. You can also override that information here via that actions menu. Press number 3. Would be good for things like turning on compressors. If you wanted all of those compressors to come on at one time, you could go in and you can override that suction pressure above the set point and bring them all on. Again, it allows for the logging, graphing, point overrides, manual defrost, that type of stuff, all from one central location. All right, let's talk about the E2e networks. RS-485 and Ethernet networks. So what is RS-485? Our RS-485 is really just a wiring protocol, is what that means. That's just saying what type of wire that we're going to use, if you will. The actual communications would be, in this case, our I/O network. This would be our communication protocol. I/O network, Modbus, Linux, things like that. So the I/O network is used for connecting boards that are built by Retail Solutions, Emerson, now instead of CPC. Things like our input boards, our output boards, multiplex RTUs, ESR boards, those types of devices would be communicating back to the E2 under the I/O network. Then we have the Modbus form of communications for things like our DICSL devices, our universal XRs, core sense modules, leak detection panels, things like that that are going to speak on the Modbus. Linux S-Bus, which would allow us to talk to the older Linux RTU units, the old IMCs and the Prodigy controllers. We have Control I/O support there as well. And then the one underneath that is support for the Novar RC family of end-of-line devices. So if one of your customers out there happens to have one of these devices, you can simply pull their old controller off, put ours on there, and then we can communicate back down to their devices on that comm loop. Kind of gives them some options instead of having to go through and remodel the whole store because of an outdated piece of equipment. They can now just put our device on there and communicate with all of their modules that are out there, saving them some money. We also support BACnet MSTP through those 6 COM ports. As well as peer-to-peer communications between the E2s by Ethernet through a full duplex 100 megabits per second WAN or LAN connection, and BACnet over IP. So these are the types of Ethernet and RS-485 communication protocols that the E2 supports. So let's talk about the rules of engagement here. No 2 different protocols can be used on the same network, meaning we cannot have this device, our I/O network, and this device, our XRs, on the same comm loop. They do speak 2 different languages, all right? Modbus being the one, I/O net being the other. Both of those devices would have to be on their own separate comm loops. An example there would be all I/O devices on COM2A and COM2B, your DICSL Modbus devices on 4A, 4B. Okay, we cannot mix those 2 languages. That being said, the baud rates also have to be set the same. Okay, baud rate again is the speed at which those devices communicate back to the E2. So we cannot have a, let's say, an I/O net device plugged into COM2 set for 9600 baud rate, and another I/O device on that same comm loop set for 19.2. The 2 devices would not communicate back to the E2 due to the conflict in the baud rate. On the Modbus BACnet MSTP, no device can occupy the same address. Whereas if you had one of these devices that was BACnet or Modbus and another device, you cannot have them both addressed as number 1. One item would have to be number 1, the other number 2, 3, 4, 5, so on and so forth. Now, with the addressing, on the Modbus, you do not have to go sequentially. So you could have one device addressed as number 1, another device addressed as number 3. You do not have to have another device addressed as number 2. However, with the CPC IONet, each device must be addressed sequentially starting with 1. So therefore, we can't skip numbers. We have to go 1, 2, 3, 4, 5, so on and so forth on down the line. And again, guys, termination. Termination resistance is required at both ends of the comm loop. I can't stress that enough. Terminate, terminate, terminate. Please terminate. All right. So once we have everything connected, now we need to go in and we need to tell the E2 which COM ports are going to be what. All right. To do so, you're going to use the menu 731. It's going to take you to the serial tab. From here, you can specify what COM1 is used for, or COM2, as well as the baud rate of said device. All the way through COM6, where we get into the Modbus devices. So this is where you're going to go to set up the communications protocol for the devices that you have out on the store's floor. All right. Adding and modifying the RS-485 network is done through menu 772. This is where you're going to go in and you're going to add devices, IO network, ECT, third-party, Echelon. All of those are going to be added through those menus. All right, so let's talk about the proper daisy chain of wiring the devices. A daisy chain looks like this. We're coming out of the E2 with one cable into our first device, out of that first device into the second, out of the second into the third, so on and so forth. So proper wiring is key with the communications of these devices. All right, so to view the network status, this is where you're going to go in and you're going to see all of the devices that are communicating with the E2, provided that they have been added, like we did with the previous devices there on the previous screen. Right here. These devices that we added here will show up on our network summary screen. This is where you're going to go in. Like I said, you're going to be able to look at all of the network that is connected to the E2 and quickly determine if it is communicating or if it is not communicating. It will also show you your communications protocol. Is it an IONet device or a Modbus device? Shows us our address of the said device right out here on this side. So guys, that's what we've got. Open it up for questions or comments.
Thank you, Dustin. Let me get over here to chat and see if we have any comments. We did have a comment from Dennis Brown. Just to clarify, he says the CX does not stand for convenience store. It is actually combination controller, as it allows you to combine the RX and VX controllers.
Okay.
He says you can actually do 2 rack in a building with one CX 400 as long as you don't exceed the IO capacity. So just a couple of comments there from Dennis.
Thank you, Dennis.
I don't know if he is still on. If there are any other questions out there, I don't see any other questions or comments that have popped up. Certainly appreciate the overview that you've given here, Dustin.
Thank you.
And let's see, nothing else has come in yet. I'll tell you what, I don't know if you're presenting tomorrow or if Don is. I don't know if we've figured out the schedule yet for tomorrow.
Okay.
But we will certainly get that out to everyone. And again, feel free to those of you on the line, feel free to forward this invitation on to others. Actually, we did just get a question from Kevin McClanahan. What is pulse accumulator?
Pulse accumulator. Okay. Oh, goodness. That's a good question. Caught me off guard with that one. Pulse accumulator. Let me find out for you.
Okay, I'll tell you what. We will, when we send out the link to this, when we send out the link to this, we'll send out the answer to that question. Kevin, you have stumped the expert. You've earned yourself a free roll of toilet paper. So that's coming your way. Yeah. Yep. For those of you that are going to join us here at the 12:30 call, we're going to have Brian Beinachek on talking about product selection software. And I'm hoping to also put out there for everyone what the schedule is going to be for the rest of these classes, at least for the next week or so. Let's see. All right, and we did have a kudos from Dave Dowland saying, you know, we at Emerson talk in a lot of acronyms and terms, so thank you, Dustin, for clarifying what things like DRAM and PIB, PIB and DRAM are. So we need to, that's a good point, Dave. We try to clean up all of our code language, and we'll try to do a good job of that moving forward to make sure you know exactly what we're talking about.
Okay. So real quick, for your answer to your pulse accumulators, okay, it is used for accounting application is what it is, such as flow meters or water or gas application, something like that, where you're taking account. So basically, it's a counter.
Perfect. Okay, well, again, thank you everybody for logging in and joining us this morning. We'll talk to a lot of you here in about 15 minutes. Again, thanks, Dustin. And we'll send out this recording of this. Feel free to share it with your organization and with your customers. Everybody take care.
Thank you.